In this video, I'm going to demonstrate how to do a problem from my money and banking homework set that I've written in myopenmath.com. Money demand is given by this equation. It implies there's a negative relationship between the nominal rate of interest and the quantity of money held or the quantity of money demanded. This is money supply. It implies that in the short run, there's no link between nominal interest rates and the money supply. The equilibrium money supply is 60.8. I'm going to copy this and paste it right here. To calculate the equilibrium nominal interest rate, I'm going to copy the right-hand side of money demand and the money supply equation and paste that into Excel. Then I'm going to backspace until I get to the coefficient and type multiplication. So what this does is it plugs the quantity of money into the money demand equation. I get a nominal rate of interest of 5.2424. I'll copy and paste that into my open math. To pull the economy out of an inflationary gap, the Fed's going to conduct an open market sale. Suppose the Fed conducts an open market sale of $2.6 billion. So the open market operation is a negative 2.6. If the multiplier is 1.3, the change in money is equal to a negative 0.6. And we multiply that by the money multiplier, and we get a change in the money supply of $3.38 billion. It's negative because the Fed is withdrawing monetary stimulus. Now the money supply, remember, was initially 60.8. So I'm going to put that up here. And it's good to label things because then you kind of lose track of it. The new money supply, MS1, is then equal to 60.8 plus the old market operation. So the new money supply is 57.42. Now you didn't have to compute this because I did it for you, and I'll show you here. Right here, 57.42. So the money supply is going to decrease. So we're going to write decreases here. Open market operation decreases the money supply. So graphically, we have this down here. We're initially right here. The nominal rate of interest is low. The Fed does an open market sale, which pushes interest rates higher. If you were to present this in class, you would have to label this I for nominal rate of interest. Label this M for quantity of money. Label this MS0 for initial money supply. Label this MS1 for final money supply. And label this money demand. And then you'd have to dash a line over to here, and dash a line over to here, and then write the two equilibrium values right here. Now I got to calculate the new equilibrium nominal interest rate. So how I'm going to do that is I'm just going to copy this. I'm going to make one modification here real quick. Instead of typing 6.8, I'm going to click on 60.8. Now you're going to see why I did that in a second. Copying this below the final money supply calculates the equilibrium interest rate instantaneously. I'm going to change this to I1. So the new nominal rate of interest is higher. And I've evaluated money demand at the new money supply. So I'm going to copy this back into my open math. Now, why does the Fed want interest rates to be higher? Well, I had said earlier that we were in an inflationary gap. So if we're in an inflationary gap, how do we know? Well, if you graph aggregate demand, short aggregate supply, and potential GDP, you'll see that we're in an inflationary gap. The graphs of these three lines is done for you down here. So this is real GDP, Y. This is price level, PL. This is short run aggregate supply in the Keynesian model. This is long run aggregate supply which is equal to potential GDP. And the downward sloping black line is initial aggregate demand. And we happen to be at this point right here. So real GDP is more than potential. Notice the price level is equal to the intercept of the Keynesian short-run aggregate supply curve, because there's no slope here. You just copy the intercept of the short-run aggregate supply curve to get the equilibrium price level. Now, to get the equilibrium GDP level, I'm going to copy these portions of aggregate demand and short-run aggregate supply into Excel and then do a little algebra to get real GDP. So what I'm going to do is I'm going to backspace until I get to Y, real GDP. And then I'm going to get rid of that equal sign. This is what the short-run aggregate supply is equal to. And this right here is the aggregate demand curve. I'm going to solve that for Y. So the next step is to do what? Add this quantity to both sides. So I need to delete the negative sign symbol. And then subtract this from both sides of the equation. And then finally, divide both sides of the equation by the slope. Now if I hit enter, Excel is not going to calculate anything. So what I have to do is I have to get rid of the equal Y. And then put an equal sign in front of this. So initial GDP, Y0, is equal to 22.00714. So equilibrium real GDP is just over $22 trillion, and equilibrium price level is just below 20. This value here is just below 20, and real GDP is just over $22 trillion. The output gap is found by taking this and subtracting from it potential GDP. So I'm going to take potential GDP and subtract it from what we just calculated, real GDP. So the gap equals initial GDP minus potential GDP. So the gap is $1.39 trillion. I'm going to paste that into my open math. The unemployment rate is less than the natural unemployment rate at this point. Next, I want to show how monetary policy in scenario 1 up here affects this model, assuming inflation expectations are constant. If inflation expectations are constant, the real rate of interest rises, because if the nominal rate of interest rises and inflation expectations are constant, according to the Fisher effect, the real rate of interest rises by the same quantity. So I need to calculate the difference in nominal rates of interest. The difference in the nominal rate of interest is equal to the final nominal rate of interest minus the initial. The nominal rate of interest went up by 0.58136 percentage points. How does this affect aggregate demand? Higher interest rates are going to decrease investment expenditures and exports, resulting in a new aggregate demand curve. Now notice aggregate demand's intercept is 29.2 initially, but 28.6 after interest rates rose. That represents this drop from 29.2 to 28.616 in aggregate demand's intercept. So the red equation corresponds to the final aggregate demand line. So now I need to find what real GDP is on the new aggregate demand. Notice that short-run aggregate supply, intersect at long-run aggregate supply. So this value should be equal to potential output. So I'm going to venture a guess here. I'm going to guess 20.617, because that's what the graph is saying. Now notice the price level does not change, because there is no slope to short-run aggregate supply. So I know that the price level is the intercept of short-run aggregate supply. Actually, this 20.617 doesn't go here. I need to put it on my spreadsheet, right? So the original price level was the intercept of short-run aggregate supply. The final price level is the same thing because the short-run aggregate supply curve has no slope. I'm going to move this over here so I can calculate the new GDP level. And I don't ask for these new values, but you have to calculate the percent changes, so you kind of have to do this. Okay, so I just copied the method or the solution from initial GDP. What's the difference between final GDP and initial GDP? The 29.2 here is the intercept of aggregate demand. Instead of 29.2, notice the slope is 0.42 still. The new intercept is 28.616. So I need to change that to 28.616. And I divide that by the intercept of short and aggregate supply, subtract from it short and aggregate supply's intercept, and then divide by the slope of aggregate demand. As expected, the value of final world GDP equals potential. So the initial gap was $1.39 trillion. The final gap is 0, which agrees with the graph. The economic growth rate is equal to what GDP is minus what it was divided by what it was times 100. The economic growth rate is a negative 6.31829%. That goes right here. Real GDP decreased by 6.318294926%. The price level is unchanged by 0%. So in the Keynesian model, restrictive monetary policy is not deflationary because in the traditional Keynesian model, the short and aggregate supply curve is perfectly elastic because in the short run, wages are sticky. Down here we have a neoclassical model of the economy. The only difference is the short and aggregate supply curve. So now we have the same aggregate demand curve, but we have a short and aggregate supply curve with a much smaller intercept and a non-zero positive slope. So I'm going to copy this part here into Excel. And the cool thing is all I got to do is change the right-hand side of the solution. So that's the Keynesian short and aggregate supply. The neoclassical aggregate supply is 1.47 plus 0.84y. So on this side, I got to replace the 19.957 with the neoclassical short and aggregate supply. So the difference between this and that is I've added 0.42y to both sides of the equation. What is the next step? Well, the next step is to subtract 1.47 from both sides of the equation. Next, factor out the y on the right-hand side of the equation. Next, I can divide both sides of this equation by this coefficient. Now, Excel won't calculate that until I get rid of the equal y and put an equals in front of that expression. Now, GDP is 22.00794. Pretty close to what it was initially before, right? So I'm going to copy that to my open math. The price level has to be computed a different way. Remember, this right here is the short and aggregate supply in the neoclassical model. So I'm going to replace the Keynesian price level with the neoclassical short and aggregate supply curve. I'm going to substitute in for y, the real GDP level at the initial equilibrium. And it equals 19.95667, or to 3 decimal places. Oh, it's the same as it was in the Keynesian model. It's not coincidence. I did that on purpose when I built a model. The output gap is the difference between what real GDP was and potential GDP. So 1.390937. Again, the unemployment rate is less than the natural unemployment rate. All of our answers here are almost identical to the answers in scenario 2. Real GDP, equilibrium price level, output gap, these three things are all identical to what they were in scenario 2, right? I'm going to copy this rise in the real rate of interest because that's what happened in scenario 1. I'm going to note that this answer is decreases. In scenario 1, the monetary policy, assuming inflation expectations are constant, the real rate of interest increases by 0.58136%, which again decreases investment expenditures and exports, and results in this aggregate demand curve. So I'm going to copy this and use it in the Excel spreadsheet to determine the new equilibrium GDP level. Now it looks like the equilibrium GDP level is going to be equal to potential. To find the new equilibrium real GDP level, I replaced the initial intercept of demand with the new intercept of demand. The old intercept was 29.2, the new intercept is 27.488. So all I have to do is change that on each one of these lines down here. I'm going to paste this value because I don't want this value to change when I change these. Okay, and here are the calculations where it's really important. So I've changed the intercept of aggregate demand from what it was originally, 29.2, to 27.448. And I get a GDP level that, well, that looks pretty close to potential. So final GDP equals potential. The output gap is 0. The economic growth rate is the same as it was in scenario 2. So economic growth is negative, which implies real GDP decreased. If you look at the graph up here, the price level was here. It is now down here. So the price level decreased too as a result of the monetary policy. How much did it decrease by? Well, to calculate that, I'm going to pull this down and then double check. So 1.47 plus 0.84 is my neoclassical short and aggregate supply. I'm substituting in the new GDP level. My new price level is 18.789. My inflation rate is found by taking what the price level is, 18.789, subtracting off what it was, 19.957, dividing that difference by what it was, 19.957, multiplying by 100. So prices fell by 5.85268%. Because this has decreased, I don't need the negative sign here. So in the neoclassical world, monetary policy is deflationary. So in 4 here, monetary policy is less deflationary in the Keynesian model than it is in the neoclassical model. And I'm going to submit my answers and hopefully I get everything correct. So far, so good. Notice I don't really need to round, which is kind of cool. So if you copy your answers in from Excel, just leave them like that and you'll get the correct answers. Oh, I love all those green boxes.